Okay, hello. I'm Pat Link. I run Neston High School Makerspace. We're based in Neston High School. As it says, I'm the teacher there for engineering, 3D product design, and I'm the facilitator of the Makerspace. The reason I say facilitator of the Makerspace is a Makerspace I set up was students like making, and we had to really incorporate that, but we had to nurture that making. Because when you say I want to make something, they come with the biggest castle they want to make, the biggest amount of cardboard, the biggest object they want to build. But I wanted to focus it a bit more, trialing, experimenting things they maybe had never done before. So students in my classroom are allowed to use any kind of machinery I showed them, and if I'm confident that they are using it. So I let them use the 3D printers, they can use the lathe, they can use the drills for making their projects, but they have to share what it is first. It's not just for the sake of coming in and knocking two nails into a board or something like that. It's like they want to come and solve a problem, and our system helped them with that. We nurture that, and we call that our maker space, because we're going to they have the opportunity, everything they can learn to weld. So we offer a huge variety of skills that we're going to put out there. You can't offer them at GCSE, but you can offer them as an extracurricular thing. And students always thank me for that, when they go like off to A-level and stuff like that. They talk about how great that was to use an interview, what I made in the Makerspace and things like that. So what we've done is we've set up Neston High School Makerspace, and we use a plastic recycling project. We started this plastic recycling project. I started this as an NQT. I've always used HTP, which is number 2 plastic. Now, when we use this, it comes in various forms. So the forms we tend to get it into is milk bottles. Milk bottles is the main part that we get it into. And we get in that main function of a milk bottle. How it works is it comes in, sometimes it's washed, sometimes it's not washed. And when it's not washed, we end up washing it. I'm going to show you later on. We devised something really great for that. But they come in like this, so we just collect them. We collect as many as we can, because the important thing about collecting as many as we can, you will go through a lot of plastic bottles when you start making stuff and building things. So I found Precious Plastic. Precious Plastic was set up by Dave Hawkins. It's been running for, I think they're in the 10th year now. It might be longer than that they've been running this. And it's a community of where they looked at reducing the amount of plastic that we use, because plastic is it basically is a one-use material unless you recycle it, because once it's made from crude oil, you're not turning it into something else, because people tend to just throw it away and not see something else in it. And we seen the thing in, you can make things with it, and you can make really practical things. And you don't need much to start out with, but what you're going to make is going to be quite precious. We just used a panini maker, a pair of scissors, that's how we started, a bit of greaseproof paper, and then pressed things into it and made our parts. After doing some fundraising, what you probably have to do, and trying to get some money together, unless you've got very deep pockets as a school, we then finally managed to get together. I managed to source together from Filament a little shredder. This was the early type shredders they had coming out, so it run off 2 gears or so. We used to do it hand-driven, but I can tell you, hand-driven, you have to be like the Hulk to turn it, otherwise you're not going to turn this. It does take a lot of manpower to get this to turn around, to crunch something up to it. We did then use this, and I'm going to come on to what we've done, but even from that basic thing that we've done is we start making projects. I use it on the lathe, I use it for demonstrating things, how to turn items, how to create items. The great thing about doing that is you can use that, anything that's waste from it, you can remelt, reuse again, so it's not like a one source material. It's a material you're going to use over and over and over again. The waste is actually useful material again, because it's finer than the actual shredded part that you have, and you can make very good components from this. So what we've done is then, from that point, we move forward to when I joined Neston High School. I had the great opportunity to have a technician on board who first was quite reluctant about the project, because he wasn't too sure, but when he's seen what the project was, he was really focused on it. He was really focused, and he said, yes, that's what I want to get involved with, because he's seen the parts. So he helped me. We built the shredder, we fundraised, got money together, bought a motor, then we made, together with students, built also the adapter plates to set the shredder up onto it, used an industrial style oven that we use for heating up other plastics and things like that in the past, acrylics. Leaks a bit on air. I come to that later on. What the problem with that is, if you're losing temperature and things like that, it's very you need to be very specific with that when you are melting plastics. And I'll talk about fumes as well, because there is gaps around these that quite struggle with this part, the gaps that come around to it. So we went from building the shredder. We then share regularly videos of us making stuff, where we started then to build the actual shredder, built a housing around to it, started building a bottle press, because we realized that the little 6-ton press we had was not big enough for pressing items that we were making, because we ended up going through a spree of making loads of items. We started out, the first thing we made was we looked at bowls. So we just wanted to do a basic bowl form, but what we found was making bowls that if you used the material and didn't use the right amount of pressure or something like that, you may end up with something like this. So you may end up with something that looks very much like spaghetti stuck together or something like that. Or you may end up with something like this, but we got the temperature right, so it's nice and glossy on the outside, but then we had too much surplus material around it. But at some spots where it's even so thick, the material, you won't see this on camera, but you trust me when I say this, if I put my finger there, I can see my finger through this. So it is wafer thin at one internal point, even though the bowl is very strong when you knock it and tap onto it. So we had different ones, and I share these regularly with students, say what goes wrong, and we talk about these and make these as debates. So that's what we thought we had to improve from what we had. So we started improving was, if I was able to draw it in CAD or sketch it on paper, Colin was able to make it. That was the great thing. So Colin could make almost anything, he said, if we can sort of bring it across like that. And we used that sort of both our knowledges together and brought it all together and started obviously building things. So we made our first bowls. The bowls that I just showed there, we used the 6-ton press for it. We put on the laser cutter and made our mold for it. Used stainless steel bowls. What we found was, speaking with Brothers Make, when I spoke with them, I'm going to share something in a minute with you there. With Brothers Make, I started speaking to Brothers Make, and Matt from Brothers Make, we started really chatting along and talking about things. He said, maybe you have to heat your mold up. So I tried that, heated the mold up. It seemed to work better. Then I spoke with Arthur from Plastic-Tastic, and he said, maybe look at your clamping pressure. So we added more bolts around the actual ring. It improved it. But then we got to the point we didn't like the outcome from the ball. Came out quite nicely. So we had a small ball that came from it. Feels nice, looks nice. But then on scrutiny, we were looking at it going, we're not getting this even. We're not getting the walls around this even. This is not going to be a product that you can use and say, this is a finished selling product. We need to make something that takes that one level up, because we wanted to make something, have one unique project. So what we came up with is, then Colin said, off that mold that I showed earlier on there, off this pattern, what we've created a mold, a new one that uses clamps and loads of pressure to go together, and we actually produced then bowls that look like this. So we have bowls that come out, and these are plant pots, and these come out really nice. So we get a nice finish onto them. But the version I'm showing you here is with the really nice finish. This was version number 6. I've only got on me version number 2 and 3 because I left the other ones in work, but I can show you. When we reduced the amount of material that we used, because the bowl weighed 650 grams when it was finished, so we decided, let's reduce it, go to 700. If you only put 700 grams in, you end up with a bowl that looks very unfinished. It's got nice surface texture to it in certain areas where there's enough material, but where there's not enough material, we're getting voids and air pockets and bubbles, because we found there was not enough mass inside the mold when we were pushing it and forcing it together for it actually to expand out. As you can see in the bottom image on the on the version 2 bowl mold, the hexagon one. And there we had enough material when we squashed it, so it came out the top of it and goes over the top, so we get a good finish. So when you get the temperature right, this was our latest version that we've tried. If you get the temperature right on the bowl, you get the right amount of material into it and you press it, you get a fairly good finish to it that's without much cleaning up, comes out as a finished product. There's little things that you finish off then, so you might clean edges off to them and you might tidy them up or something like that. But that's what we found. But that was something we looked at because we wanted to look at the moulding making side. But then we thought, hold on, that takes quite a long period to get to that. Melting plastic, we're heating it up into oven. We have to then look at different ways of storing because you have to heat the mold up. So there's multiple things, setups that you need. To do a bowl probably, we reckon we probably need 2 to 3 ovens. 1 to heat the mold up into, 2 to have different types of amounts of plastic if you want to marble something together. So it's a huge making process in that. So we thought, I have to get that into school. And the way I got into school was we looked at making coasters. At one Makefest, a maker came to me and handed me, he asked me prior to it if I can share my waste PLA with him. And I asked him what was it for, and he said, well, you do 3D printing and I make coasters from these. I come and see you at Makefest. So he came and see me at Makefest and he handed me a coaster. When I had this coaster in my hand, I was like going, wow, I can't believe. He said that was made from, so we looked at the coaster side of it. It's a really nice a project to grab hold of. So we started making coasters. And we've got coasters we made of these. I think we must be on like coasters, if I counted them, probably 50 or something like that or more. Because when we make something and you have waste plastic that comes up, we throw it back into the oven and make the next coaster. So we don't let the plastic go cold. We squash it straight away, put it in there. And when that happens is, later on we just trim this off with woodworking tools, clean them up. And then when you clean them up, you end up with a nicely finished coaster. And students said, because we done like a poll online, and they were saying this is something that we could market, this is something that we could sell. So we looked at that part. The mold for it was just simply made on the laser cutter. We used locating pins the way you use the same on industrial made molds. So we talked to students about how you have to have locating pins on there and done that. The problem you find with the MDF one is after about 10 to 15 times using it, if you don't use it correctly, you can squash the MDF. You can, because you're using tons of pressure, you can damage things, so you might have to re-laser cut them again. What we found was you can cut them down to smaller sizes, or unfortunately had to go to waste then. Now, to make that a really interesting project, what I started doing was, because I like to engage students, get them inquisitive and want to be engaged. So I found was, because to share an experience, the best way is, if you take photographs, I started playing the game with them, the first 9 pictures from my experimenting of today. And I always call a maker's gonna make with the hashtag. So the maker's gonna make, but you take photographs and you just share. And it was a good way of showing the when we done something, so that shows the process of us making the ball, because we done like a little short video with that, and we done a couple of image shots from it to actually record that, how we made that. And if you click on the Instagram one, which I'll share later on, but when I share the PowerPoint, it will be on there, so you don't have to make a note for that. So it'll take it across, and I'll show you what we put on there. So we could put a whole series of videos over onto our Makerspace page, and on this Makerspace page where we put that on there, we've got loads of posts on there, like we had our new stamps made, things going into the oven, different videos of us manufacturing, building things. We put quizzes on there, we put just collection posters, building process, and this is something the students really get engaged with because they want to see this. And that was when I was talking about Maker's Brother before, when I got in touch with them and I joined up. Well, I joined up with them because I watched their YouTube videos and we answered a couple of questions to each other, and then I joined them in a Patreon group what they had, and we shared stickers then and stuff like that, and we can share loads of information with it. So it was great as a community to do that. So we should share on our Makerspace everything that we do and put it down. Then it goes back, and the great thing about this was students engaged with this, and the students engaged really well when we done this. So it wasn't like a part just I'm going to do it for a short second. It is an ongoing thing. So what we've done then is, after doing the 9 pictures, this is what we've produced in the, trying to think, from February lockdown starting, from our lockdown starting up until probably 3 weeks into it, we produced what's lying on the table here. This was experimenting with, so we made chopping boards, various bowls that we made. So this was the first on the left hand side of the slide by the Neston High School Makerspace logo here, you can see on there these are the first bowls that we made. After making these bowls that we came over, we had chopping boards that we tried to take a lot of plastic, so it was trying to get that resource to come into it. You know, it's the thing is, it's quickly making something, but it's getting more material in, we found was the hardest part. So what we had is, I've set it a challenge. Long as it's number 2 plastic, we're taking it. We're starting number 5 as well now, by the way. But what I said is, this bottle, or this tub, is 80 litres. How many plastic bottles do you think that is holding shredded? The number for that is, if you say 10, I'm going to say you're wrong. A bottle weighs approximately between 35 grams and 42 grams if it's a milk bottle. And for example, a 5 litre antifreeze bottle or hand sanitizer bottle, those big 5 litre ones that you get, they weigh about 140 grams in that region. So you can see this is an 80 litre drum that is full that we've shredded. Our shredder now, we have to shred this 3 times to be a very fine shred, because it gives quite a coarse shred for that. On precious plastics, there was a good write-up about that. It depends on the amount of teeth you have in your shredder. It depends on the amount of sieve you have, and we don't run a sieve underneath it. We just shred it straight through. And if you sieve it back up into the shredder, you can get it reduced down to a certain granule size. Updates we've made in our Makerspace since our last production and stuff that we've done is, we have got a dedicated space where we put it into. We created a dedicated space in my classroom. We're going to have extraction so that we make sure HDP is the safest plastic to work with, but every plastic you work with, there is fumes that are caused. The fumes are from heating up. As we only heat up to 180 degrees and not above that, because you'll start burning it, 180 degrees is the melting point, the ideal melting point for it. You get fumes when you first open the oven, and that's why we always stand back or have the extraction on, always plenty of ventilation so that goes, because obviously teaching with a mask on is quite difficult even if you're wearing something, so you stand back and make sure that you're not right in the gap where it's wafting up and coming out. But we found that was quite a safe way of doing it. We had, by the way, our shredder that we built, the council came, so we had the health and safety guy from the council came, looked at everything, and he said we covered that. He looked at it and he said right away, yeah, that's safe to use in school. So there was no problems about it, because we thought of every single problem there could be. Colin and myself, we were like kids lying on the ground thinking, oh, I can put a finger in here, I can touch this there, I can touch, make sure we put a guard over this, make sure we put some there, make sure we have a micro switch on here, make sure we have a micro switch there. So we've done loads of grabbing and touching with that and made sure that was safe. So we built that shredder. That's our current shredder that we're using. We built a bottle press. This has got a stand on. Currently on the stand is, we've got loads of wooden boards that we pack underneath here so that we can actually adjust the spacing of what you're pressing. So you're pressing a thin sheet, you pack it up so you don't have to work the jack so far to come down, because we put a 10-ton jack on there, so we went for the biggest possible jack we can put on there to have the most clamping pressure on there, because the higher clamping pressure you have, the tighter the material goes and the better the quality of the material outcome is. So what we've done is I come up with a upcycled cat litter tray and some leftover timbers that I found in the workshop. We cut them up and we made ourselves a bottle drying rack. So when the bottles, like I said on slide 1, when they come in, sometimes they're well washed, sometimes they're not well washed. When you get up that, we always tend to find it, if someone brings us a bottle and the lid is on it, first thing we do is go over to the sink, open it by the sink, put some warm water into it, spill it around and empty it out. That way, if there's something left in it, you're not going to get that smell, because it's quite potent if you smell stale milk inside something, and it's not a nice smell to get rid of. So quickly, and then we put it onto the drying rack and the water evaporates off that. And students find it quite funny onto that, because they always, what they will turn around and say when bottles get delivered, oh, just leave it in the box by the front door, just leave it in the box by the front door. We have a collection box of that made in the classroom where they actually get dropped into. I'm going to try and do them across the school, these collection boxes. And what we're starting with year 9, our new project is we're going to start making a litter picker. So it's based on, first we're going to look at the mechanics of it, but then it's going to be the long-term thing to lead into the plastic recycling project, which we run as an extracurricular one, because we want to try and get that into to working for our main curriculum part. But I'll be running out to all year groups then for this to be engaged with this. Up here, this is only the update from today, so the slide was freshly updated today. On here, we made now our new storage rack, so we can actually put our bottles onto there, so we can see how many green ones we have, how many blue lids we have, because we kept the lids separate, because you end up with loads of clear plastic, or we call it clear. It's not really clear, it's more like a grey colour, the milk bottle. It looks white because milk's inside there, but obviously it's not white because it's coming through the bottle, but it's like an off-white, off-clear sort of grey colour. Then what we've done is we've then decided we're going to upgrade our shredder. This is version 2.1 of Precious Plastic. You can buy these as a kit, you can buy these ready assembled, you can buy them ready made. If you speak to them nicely, they are makers, just like we see ourselves as being makers. You can return favours to each other, you can get good deals, and we got a great deal on buying this one. I have got a teacher's page set up on Facebook called Schools Recycling Plastic, where the link is at the bottom here. I'll click over into a minute, show you the live page onto it. When I done my last time when I talked about it, we had at the current screenshot for it, it was 49 users. I think we're only over 174 now, 175 or something like that. Schools interested or making stuff with plastic. As well, we decided our industrial oven is going to go, because I talked before air leakage. We found that the air was leaking out of it, so it was taking us longer to heat up, so we're getting heat loss from it. So we bought 2 new ovens. So we use a panini maker as doing the main colour mixing. Then when you do the techniques with twisting and shredding, now for all these techniques, there's a really good Instagram one to go and look at. If you look at Instagram, Brothers Make, they link to YouTube. They run their own YouTube channel and stuff like that, and they've got very good videos and reels on there and stuff like that of actually how to make the plastic, how to finish the plastic off and stuff like that. But we've done quite a bit with this, but we use it as well. It's really good because you can go and watch something where another maker's done it, see something, try something, but we all found back it was good to share with each other what we're actually doing, so we can all learn off it. So there's like a whole amount of sharing going. So I'm doing this, or how's that working for you? What are you doing? Sort of thing. That was the Facebook group. That's worked really well for this one because it was a closed group. We do try and make sure that we only take in teachers, and we've added other people in who are not teachers, who are makers, who are interested in the same way, or who do with plastic recycling. But obviously, as it is an open block, we didn't want to leave an open group so not just anybody can join it. We wanted to keep it more to a community of people who are basically interested in recycling plastic, so we're actually making an impact there. Then with the ovens that we had, obviously I talked about ventilation before. We're in the process of designing that, because we found we have a ventilation system there, but we found it was very difficult to find parts to adapt it to, and we rather wanted to spend our money in other areas than buying loads on that. So we found we can fabricate that ourselves, the ventilation system. So we're doing that at the moment. We're in Fusion, coming up with designs that we can actually 3D print then to create our own swan neck that comes onto it. Then I've started with our Instagram one, which I think is good as a makerspace, that if you're after something and you put a wanted post out there, people will come back. I've had loads of messages off people now saying that they've got these silica bags because they just lie around when you get something delivered inside there. But we found our PLA was snapping, and we couldn't work out why our PLA was snapping, and we found out why our PLA was snapping. It was snapping because if you leave it out in moisture, it actually becomes brittle. But I was thinking moisture would become soft, but no, it actually does the opposite effect to PLA. It actually will break it when moisture comes into it. It becomes quite brittle. So we found if you put them in with silicone bags into a box and seal the lid onto it, it actually reduces the amount of moisture in it and makes it better for printing. Again, funny, we are using a box, and Colin turned around, first thing turned around, said, yeah, we can use these boxes, they're number 5 plastic. We're going to be using that when we build our injection molder as the next one. So we're really looking, if we're going to use something in plastic, what's the afterlife when it breaks? How can we use this? I've used as well a good poster that's to be used is this one here that you have on here. On this poster, I've just literally made out "we need your help" and done like a little stage. I know we're not trying to tell them how to wash things, but sometimes when you ask someone to bring something in, they just go to the bin and grab it out. It's great, the thought, I love the thought of it, but you know, the smell of it, you don't get rid of that quickly. So the only reason what we've done is we've done like a little promotional picture story saying, don't donate like this, make sure you wash it out with a bit of warm water first, dry it, and donate it like this with the lid separate. We talked about these correct lids, and we explained what number 2 plastic was. Because when you ask people in plastic, they will bring you everything, but you can't recycle everything at the moment. We look at the next ones to recycle. We're looking at doing polypropylene, so number 5 plastic, and LDP, because you get quite a few number 4 lids we found on some products that we're going to use. That is, but we're building an injection molder for that. That's the next project we're working on. And after the injection molder, we want to look at building our own filament extractor. You can buy them, and we're thinking about getting a kit there. I will share that on the social media, on the Facebook group. I've got a link to that one, and we're looking at making our own filament shredder. So the ideal thing we want to do is make something, not need it anymore, be able to shred it, then recycle it and print with it again, so it becomes that cycle, so you're not wasting a load amounts of materials. So that was my presentation in a quick run through there, talking about how I set up plastic recycling inside schools. And we're using this, it's going to be rolled out now up until the summer, and we're hoping, as from the new curriculum year starting, that we're going to roll this out as a permanent one. So I talked on here before, the Facebook page that we set up, and you can see on this Facebook page, so like there's now someone coming in asking to join, and we are at 100, and like I said, 174 members on there. And it's great for the community, is because there is loads that gets put onto here. No, it's not showing me now. Tends to show you the pictures at the top that you put into there, so you can see where people use different ways of using shredders. They use paper shredders, things what people have bought. The good thing is everybody tells you in here when they get it from somewhere. We're sharing back where we got it from and sharing our experience with it, because there's companies out there who will sell stuff, but you can pay a fortune for it, and with a bit of knowledge in making or doing something, you can make things for yourself.